Hello, everyone. Okay, so yes, welcome to this lesson where we're starting to have a look at cancer biology. Um, the first task has been to have a look at these graphs that show data on incidence and prevalence in different cases of different cancers within populations, all mostly UK, I think, European in some cases. Um, and I've asked you to have a sort of look at what these graphs show. What are the trends? First, the incidence. That word means the number of new cases in a year that occur within the population. Prevalence is the number of cases in total within the population at any one time for the disease. So incidence rates tell us perhaps can indicate whether there's a surge in cases within a particular year. We might expect incidence rates to be constant. There might be new diagnostic techniques that mean that incidence rates go up, for example, or there might be practices that, things that are occurring within the society that that are increasing people's chances of developing a certain cancer. So incidence data is useful, as well as prevalence data. Prevalence data tells us the total number of cases, the burden of that to society. Perhaps it'll give policymakers an idea of where to distribute resources, for example, um, in terms of treating those and supporting people with those cancers. The first graph shows up to, so we're within, in the year 2003, the numbers of new cases and age, by age specific incidence rates by sex for breast cancer. Firstly, you'll notice that the male rates, which are down at the bottom there, are very, very low, but males do get breast cancer. Males have got breast tissue, and that can develop breast cancer. Um, Obviously, the rates are much higher in women. We see it rise and then fall away again. So the peak is around 55 to 59. We have our highest incidence rate. And there's a little bracket around that to show that those are the age groups that are screened as well. So we might expect a kind of higher incidence rate once screening begins. Um, so we see a bit of a dip as people get older and then a rise up at the end, perhaps. We could suggest why there's a dip in incidence rates. Um, the simple answer is there are fewer people in those age groups, and that might be why the incidence rates are dropping away. Um, Breast cancer occurrence is strongly linked to the sort of menopausal time, that the hormonal changes that occur, whether that's a causative thing, or a risk factor. When we're talking about cancers, it's very important to perhaps move away from things that cause cancer to start to think about things that increase your risk for developing cancer. Um, it's very difficult to highlight anything as a causal factor for cancer. As we've looked at in lessons on mutation, um, mutation is a random event, and also errors can be corrected and all that kind of thing. And as you'll see in the next lecture and the one after, you'll see how specific genes need to be mutated in order for cancer to develop, and that's random, and it's down to chance. So um, most things that can induce mutation um, can are risk factors for cancer, but that's they are risk factors rather than causative agents. Um, then the next graph shows age standardized European incidence and mortality rates for female breast cancer. Here we're looking at mortality rates. You'll see that remains fairly constant at 40 per 100,000 females, but then it starts to go down, and if that graph continued on to 2020, we would see the mortality rates declining. Mortality rates are declining because we're getting better at diagnosing and then treating breast cancer. Incidence rates are going up, and you would suspect that's probably because there's an increased amount of testing going on. So perhaps not that there's an issue with more women than have done in the past suffering from breast cancer, but better testing to identify incidence rates. The next graph on slide 5, age-specific incidence rates, again female breast cancer in Britain, 1975 to 2003. And we can see by age the you can see the challenges faced by people trying to work at home. Yes, in the age group 15 to 39, the rates are very low. In our 70 group, they're the highest incidence rates. So although we saw it dropping away in that first graph, I suggested that was probably because there were less people in that group. But if we look at rates per 100,000 females that are 70 plus, then they're in the highest incidence group, and the levels are going up again. Probably through increased testing, and there were campaigns like encouraging women to attend screening, do self-examinations and that kind of thing. The graph on slide 6 shows age standardised European incidence rates for lung cancer by sex in the UK. We see males at the top, females at the bottom, relatively constant levels of lung cancer in females. Males, it's going down. Persons in total, you can see lung cancer rates at kind of 1993, it's sort of nearly 58 or so per 100,000, going down to about 48, 47 per 100,000. So rates were going down overall for people developing lung cancer. The lung cancer, as you probably know, is strongly associated with smoking. So these graphs probably represent trends in smoking. Males have traditionally always smoked more than women, higher levels of smoking in males. That there tend to be more males historically have smoked than women, and males will also smoke more cigarettes a day than women is a recognised trend. So that probably explains why males are consistently higher than females. And I think over that period, 1993 to 2003, there's been a lot of health campaigning targeted at men, but targeted across the population to reduce smoking rates. Males have maybe taken this up more than females, and certainly they have more to give up, and that's why those levels have dropped away. The graph in slide 7, age standardised incidence rates by deprivation category, is an interesting graph, and it shows two lines, males and females, least deprived cancer rates are lower than the most deprived. So there's a link there of deprivation and risk for cancer. Again, it's you'd have to surmise as to why that link is there, but it's perhaps due to access to healthy lifestyles, healthy choices, education, those kinds of factors. I'll speed this up because it doesn't look like I'll be able to keep going for too long. There's slide 8, 20-year lag between smoking and lung cancer. Really, really interesting. You can see the number of cigarettes smoked per person per year, and this is in men, has gone up and up and up from 1900 to 1940, 1945, and then it starts to come down a little bit on this graph. So we saw, yes, larger amounts of cigarettes being smoked per year by men, and we see the very characteristic shape of the graph is the same for lung cancer incidence, or sorry, lung cancer deaths per 100,000 people. Um, and there's about a 20-year lag time between smoking and lung cancer. So again, that there is a correlation there, or certainly a matching pattern in those graphs that's suggestive that there is a relationship between smoking and lung cancer, but that relationship doesn't become apparent for about 20 years. So there's a good 20 years of smoking. Um, it's an opportunity for me to reflect personally. I gave up smoking after more than 20 years of smoking. I was certainly in the very low number of cigarettes smoked per year, but still, when I started teaching this, it made me, much more aware of the importance of quitting sooner. Um, and the last graph, reflected on that last graph, you can see cumulative risk on the y-axis by age, on the x-axis, and we've got a series of lines here about people who've stopped smoking. I say people, across the population, stopping smoking. So the lifelong non-smoker risk is that line down the very bottom. Um, so lung cancer rates in lifelong non-smokers are very low, as you can see. Sort of less than 1%. If you stopped smoking at 30, that by the age of 75, your cumulative risk has probably gone up to kind of whatever that is, maybe 1.5%. So that's it's probably maybe tripled or quadrupled your risk compared to a lifelong non-smoker. If we put the kind of lifelong non-smoker at just above 0%, 0.25, and it's kind of like 1.25, 1.5% for a stop smoking at 30. But then there's a line. There's if you stopped smoking at 60, you've got a lifelong risk of over 10% or so, perhaps 10% of death from lung cancer. So the graph shows the sooner you quit, the better. Okay, thanks everyone.